including lines. Today, you'll work with your team to apply what you know to more complicated polynomial equations. Discuss quadratic polynomial equations can be written in standard or factored form. Other polynomial equations can be written in standard or factored form. For example, y equals x to the power of 4 minus 4x cubed minus 3x squared plus 10x plus 8 is in standard form, but it can be written in factored form as y equals x plus 1 squared, x minus 2, x minus 4. During this lesson, you will develop techniques for sketching the graph of a polynomial function from its equation, and you will just define why those techniques work.
Okay, thank you, Samar. So let's talk about pros and cons of both. Because some forms are better than others. Just depends on what you're trying to do. And you guys kind of just sort of spitball, tell me what you guys think. So let's look at standard form. Standard form is when it's all drawn out like this. x4, 4x cubed, blah, 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 whatever, right? What do you think is the advantage of that? What can that tell us, the standard form? I'll ask the question. What's the y-intercept of this equation here?
8.
Yeah, so you got it pretty fast, right? One pro is the y-intercept. Easy to tell. Can you tell what the x-intercepts are just by looking at it? Probably not. I'd say it's a con. Another thing we're going to talk about is end behavior. I would say it's a pro. Did we talk about end behavior last semester? Did we? I don't remember. We'll talk about that in a little bit. But end behavior is looking at how the ends of the graph behave. We'll talk about that's another pro. Okay, let's talk about cons. Sorry, let's talk about factor form. Okay, factor form. If you want to find the y-intercept, what would you have to do for the factor form? You have to plug in 0 for. If you want to find the y-intercept, what does x equal? 0 for x, and then you have to do some computation, right? You have to do 0 plus 1 squared, 0 minus. I mean, it's not hard, but I'd say it's a little trickier because you could just get it straight up from the standard form, right? But what are the x-intercepts for the factor form? What would make y0? Yeah, and that's easy because it's already factored for you. So it's kind of reverse. So sometimes the factor form is better, sometimes the standard form is better. So it just depends on what you're trying to do. Also, another pro will be bounce off the x-axis. It's easy to tell if that's going to happen in factor form. Not so easy to tell in standard form. So that's what's happening there. So now we're clear on the forms. Let's have someone so now we're going to do the activity together. Well, Alexander, can you read the next one, please? Which is the Mathemerica land? I can't even pronounce that.
Carnival Company has decided to build a new roller coaster to use at this year's county fair. The new coaster will have a very special feature. Part of the ride will be underground. The designers will use polynomial functions to describe different pieces of the track. Part of the design is shown at right. Your task is to guess a possible equation to represent the track and test it on your back and front. To help get an idea of what to try, start by checking the graphs of the equations written below. Think about how the graphs are the same and how they are different.
Okay, thank you. So let's actually do this in Desmos, and this is the part I want to do with you guys. Our goal is to match one of these equations with the graph. Now, let me ask this question. How many peaks and valleys do you see in this graph? How many valleys? How many peaks? Okay. So that's going to be important. We'll have to consider that. Also look at look how the arrows point. The arrows both point up, right? That's important as well. What are my x-intercepts, by the way? Yeah. X equals 2 and x equals 3. At 2, does it bounce across? Does it deflect off at 2? You guys see how it bounces, right? What about 3? Does that bounce across? Is it bouncing off 3 or crossing 3? Crossing, okay. That's important. What's the y-intercept here? 0, okay, that's important. Okay, we have law of evidence. We see where it bounces, we see where it crosses. Oh, another x-intercept is x equals 0. I forgot about that. That's another x, and that crosses. And the arrows are both pointing up. So there's a lot of data here. We see arrows pointing up. We see where it crosses the x-axis or bounces. We see a y-intercept. Also, we see there are a total of 3 peaks and valleys. So these are all key pieces of evidence that we need to help us make the equation. Okay, so now what we're going to do is let's take a look at these equations here. Before we go to Desmos, before we just mindlessly put stuff in a computer, bless you, think about the first equation. What are the x-intercepts for that equation here? Where is that going to cross the x-axis? What do you guys think? 0 or 2. There's no 3, right? Don't we need 3? So that's probably not going to work for me. Take a look at the next one. What do you think the x-intercept is going to be here? Still 0 and 2, but no 3. But notice says x minus 2 squared. Let's be present to that because that's going to be important. And then lastly, what are the x-intercepts for the third equation? 0, 2, and 3. But x minus 2 is back to not being squared. How's that change things? So let's take a look. So now that I've kind of got somewhat familiar with these equations, let's actually graph each one. So if I go to Desmos, x times x minus 2. Okay, what kind of shape is that? Not the one that we see in the in your notes, right? Okay, let's change that to the second power. Okay, how's this one different? Cubic, it does touch at 0 and 2. It does bounce at 2, but look at this portion here. Doesn't this portion have to be below the x-axis? Then we want something like this, right? Like that. I mean, I didn't do it quite accurately. So it's not quite there yet. Okay, let's look at the next one. How many times does this cross the x-axis? How many peaks and valleys do we have? Not 3. We're supposed to have 3 peaks and valleys. And does it bounce at 2? So now, given what we've done, it's a really easy change. What do you think the equation should be for this?
Is the whole thing negative?
Actually, not quite, because parts of it's above the x-axis. So where are my x-intercepts again? 0, 2, and 3. And what's happening too is a bounce, right? We notice a bounce when you have x minus 2 squared. So what if I did this here? Let's punch this in. Change that to a second power. Now do I get the equation? Do I get the graph? Sorry, now do I get the graph? I do. How many peaks and valleys do you see now? You see 2 valleys and 1 peak. Do you see a bounce at 2? Do you see x-intercept at 3? Do you see x-intercept at 0? The arrows are pointing the right way. So this kind of helps us to understand how the equations relate to the graph. That's kind of the whole point of this exercise. So I kind of already told you what to do. But I'll have someone read it just so someone can read it. Lois, can you read the next part? It says your task.
Has a shape close to the center, card zooming in or changing the viewing window on your graphing calculator to see the details better. Keep track of what you tried and the equations you find that fit more software.
Thank you. So you can see if you did in the graphing calculator, you actually have to change the window. Desmos, no, because what I do in Desmos, I just zoom in and zoom out with my mouse, right? I have a little wheel here that does it for me. So you don't, or you could use this button too. It's up to you. I don't really care how to zoom out, zoom in and zoom out. But you can see why this equation works, right? We have 3 x-intercepts, right? So you can put this in your notes. You have 3 x-intercepts. There's a bounce at x equals 2. Arrows point up. Both arrows, right? point up. So that's kind of important, right? So in general, here's what you kind of expect. Y equals A, X minus X sub 1, X minus X sub 2, times dot, dot, dot. This is the general way of writing a polynomial function. That's a good general way of writing it, where x1, x2 are x-intercepts. x1, x2, comma dot, dot, dot are called x-intercepts. That's one way you could write it. Another way you could write it is like this. You can also write like this: y equals a times x raised to the n power plus dot, 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 where this is the leading term. That's yet another way you could write it too. So this is what we call standard form. This is what we call a factor form. Kind of easy to get factor form from the graph, right? Because you can see the x-intercepts and put it in. It's like, okay, here are the x-intercepts. What a is not quite clear. We have to actually plug in other numbers if solve for a. But we're going to work on this in just a moment. So that's what's happening here. Okay. So we did that together. We're good there. Let's move on to the next part. Ooh, okay, this is good. Okay, this is where I'm going to have you guys kind of work with an elbow partner and kind of figure out how the graph looks, and I'll come help you guys out. So in this investigation, we'll determine which information upon it can help you sketch the graph. So let's do this. Let me have you guys work on. So you have some space down below where you can just do the graph. And what I want you to do is I want you to write the equation, draw the graph, make a table, do x and y intercepts, turning points, max and mins, domain and range. I'll do a couple just so you kind of see how it looks. Then I'm gonna have you guys try some on your own. I'm gonna do P1 and P3, and I think I'm gonna have you guys do P4 and P8 with an elbow partner. So, but let's take a look at P1 and P3. Okay, if I do P1, just by kind of doing a little investigation, what do you think the x-intercepts are for P1? If I plug in, if I replace y with 0, or set the equation equal to 0, what do you think x would equal? Go, Chelsea. 2 and negative 5, good. If I plug in 0 for x, what do I get? Well, I have 5 squared, and then net times -2. Yeah, -50, exactly right. Okay, if I were to expand it or FOIL, what do you think the leading term would be? X raised to what power? Cubed, good, excellent, good. Plus a bunch of other junk, right? So whenever the degree is odd, whenever this is an odd number, we expect the arrows to look like this, go in opposite directions. And also at -5, notice there's a square there, right? That's gonna be a bounce, by the way. That's gonna be a bounce. So if I go to Desmos and plug it all in, so it was xy equals x minus 2, x plus 5, raised to the second power. Okay, you see it bounce at -5, see it crossing at 2, and you see it goes all the way down to -50, right? And by the way, that's the low point. That's kind of hard to tell, but -1/3, you won't be able to figure that out until you get the calculus. So you have to use a graph to be able to do that for now. But that's like -1/3, -50.81, whatever. And where's the peak happening? Looks what happens at that x-intercept because it's bouncing off there. So when you go through this process, what I want you guys to do is to say this. So here's what I want you guys to do. you're going to give me the equation, which is y equals x minus 2, x plus 5 squared. You do the graph, which I'll just kind of do it over here. Graph look like this, right? Where did it cross the y-axis again? -50, right? That was at -5. That was at 2. A table. You can just do this. Just plug in like -5, comma 0, 2, comma 0, 0, comma -50. That's kind of good enough. X, Y intercepts. Well, duh, you got them. All right there. The turning points. There's a max. Or actually, just tell me how many there are. There are 2 of them. By the way, the number of turning points usually will be 1 less than a degree. So degree is 3, so we have 2 turning points. Let's see here. What else we got? Maximum values. There was a max at -5, comma 0. There was a min at -0.3, 50.81, I think. -50.81. Domain, just so you know, it's going to be all real numbers. My range, because it's going in both directions, it's also all real numbers. Okay, so that makes this how I analyze it. I use the graphing calculator or the Desmos. Take the equation, show me the graph, make a quick table. The x, y intercepts can be part of the table. That helps. Tell me how many turning points you have. Tell me where the max and min happens. Domains always be all real, by the way. This will never have restricted domain. Polynomial functions always have all real. The range can be limited depending on what you're doing. Because both arrows go in opposite directions, then all y values are covered. If you had something like this here, like we had on the previous page, then of course find the low point and say y is bigger than that, or if it's going down, then y is less than that. But that's essentially what you're doing. So I think in the interest of time, I won't do P3. I think you get the idea of what you have to do. So go and try P4 and P8. I'll do it as well on my screen. But I'll freeze my screen and I'll check with you guys in a moment. But go and try P4 and P8. Just investigate. Work with an elbow partner. Or you guys can work with like 3 or 4 people. I don't really care. But try P4 and P8. I'll check in you guys in just a moment. I'll freeze my screen. And just go through that process. Just tell me where it crosses the x-axis, where it crosses the y-axis. Give me the turning points. Give me the max mins. We're just analyzing this graph in great detail. That's all we're doing. So go do P4 and P8, and then we'll check in about a couple minutes. Yeah, what's up? Yeah, give me a sec. Punch it in Desmos first. Have you guys done that? Okay. Do you see where do you see where across the x-axis?
Yeah.
Oh, okay. Try zooming out. Try zooming in. P4 and P8. Just give me a moment because I'm just gonna work these out. Yes, the x-intercept, right. There'll be 4 of them actually for the first one. You have 5 x-intercepts?
I only have.
Just have 4.
Yeah.
It's only 4.
I only have 3.
Oh.
5.
Yeah, it seems like they're a very thinking number of the equation. So like these other.
0.
Does the graph have to be accurate, or can we just make it look like what we see?
You make it look like how you see. Does that you guys won't do a super accurate until you get the calculus? Okay. Here, I'll show you what I got so far. Here's what I got so far. I know it's kind of hard to tell. But you're gonna cross x-axis 4 times. So do you have 5 x-intercepts still, Aiden? Let me see. Oh, that's because x equals y equals. Or it's function notation. It's y equals that's why.
Wait, Mr. Yadley.
3, okay. Oh, that's what you
But.
yeah, you did too.
I thought it was.
Yes, yeah, we did before. Okay, is there a question here? No? No question? Oh, yeah, you have that question. What's your question?
How did you mean? You told us for it.
Okay, let me finish soft. You can just do a tail with the x-intercepts. Tell me how many there are. Carry on, let's come up. You done? You can use that or use your intercepts for a table. Yeah, 100%. Yep. I'll get there in a moment. Yeah. I'll summarize at the end. Okay. Here's some more I got. So -3, -1, 1, and 5 are x-intercepts. That's where it crosses the x-axis. 45 should be your y-intercept. If I clear my screen for just a moment and go to Desmos, hold on, it's x plus 3 squared. Okay, then we got what? X plus 1, x minus 1, and x minus 5. Okay, it looks kind of funny. If I zoom out, it's kind of tricky. So it does look pretty skinny. I don't like it. So I'm going to do this. Do I want x to go from -89 to 77? No. Let's go from like -10 to 10. That's kind of crazy, right? Oh, look at that. So much better. So sometimes you have to actually go to the window. Sometimes your mouse will deceive, your trackpad won't be good. Let's go to like say -50 to 50. Ah, so much better. Look at that. So see how I actually have, okay, I can't see that low point. It's really hard to tell. So see how it goes down, hold on a sec. See how it goes down to -800 roughly. So let me drop that down to like -800. Hold on, let's see here. -800, and let's go to maybe like 50. All right. Okay, so here's how the graph looks. The low point's kind of hard to tell. And by the way, the beauty about Desmos, it gives you those max and mins pretty easy, right? So you could say the max here is what? And usually when you give the max, you just give the y values. That's totally fine. Max of 47.18. That looks like a terrible 47. A max is 0 also. Where do you have low points? At negative 21.96. And one of those way down here. Yikes, negative 746.04. Excuse me. Thanks. Negative 46.04. Okay. Just peaks or valleys. That's all. How many, right? There are 4 total. And then what they are afterwards are the max and min values. So we see that. Okay, great. Now the arrows, to answer your question, Eloise, how do I know the arrows are going to look like this? So this is where I need you guys to kind of focus and let's pay attention here. So really simple. You have to look at A and N. Let me switch colors for a bit of contrast. You really have to consider both A and N. So they look like this. Yeah, exactly. All right. Here we go, guys. Quiet, please. Thank you. You cheated.
Told you. Yeah, that is,
Are grades out on?
I haven't graded yours yet because I picked yours for afternoon. I haven't done any grading over the weekend, but I could do it while.
Bob, you got it.
All right. Okay, guys, we're talking about end behavior. Guys, quiet, please. Thank you. Yeah, we're talking about end behavior. I'll explain in a moment. End behavior. Yeah. Okay, I need you guys to write this down somewhere because it's also important too. End behavior and arrows. I know it's terribly exciting stuff. How the arrows, 2 more. How the arrows are going to point. So A is the leading coefficient and N is the degree. Okay, if your degree is even, think about it this way, the arrows will go in the same direction, right? If your degree is even, as you expect, like y equals x squared, doesn't always both point up, both point down, for y equals x squared for a parabola, both up and both down. So if you have like degree 4 or 6 or 8, 10, 12, doesn't really matter. As long as the highest exponent's even, expect the arrows go in the same direction. See, even, they go in the same direction. But if it's positive, they both point up, negative, they both point down. Because as x keeps getting larger, the leading term is going to dominate, right? The leading term dominates all the other terms when x gets really large and raises to a very high power. And then I'll get that for you, don't worry. Then what about the arrows and their opposite? There you go.
Oh my God.
It's like a dog toy. Okay. Okay.
It's both.
No. There's 4 scenarios.
Okay.
A and N are 2 separate things. A is the number in front, N is the highest exponent. So when that's positive, that's even, expect this.
Oh.
When that's positive, not expect this. Okay, now. No problem. Okay. I said please, but it's all right. I know. It's like, can you move? It's like so demanding. Oh my God, jeez. It's like my kids. Like, yeah, can you do this? No, okay. All right. Anyway, if A is negative, okay, let me take it back. If N is odd, the arrow's gonna go in opposite directions. So there are odds with each other. The arrows. Think of it like that, right? If it's positive and odd, it goes down and up because eventually it's gonna end up. If it's negative odd, eventually it's gonna go down. So it goes up then down. So if you think about it, what would be the degree here? Y equals x what power? You have x squared, and how many more x's you got? So what do you think the highest power would be? It'd be 5, exactly. And what's the coefficient in front of x5? 1. No, you don't see a number, so you assume it's 1. So if your leading coefficient is positive, but the degree is odd, you're gonna have opposite arrows. The arrows are going in opposite directions. So when the degree is odd, we expect the arrows to go in opposite direction. The degree is the highest exponent after you expand everything.
Why does the negative make it so
That's because when x gets really large, great question. When x gets really large, we expect the graph to eventually go down. because what's happening is that the leading term dominates, but it has a negative in front of it. And that's when we're going to investigate. You're going to see more of it in pre-calculus too, but we're just kind of scratching the surface here. And let me go back to what I had on the previous page. Sorry, I'm undoing all this right now. There we go. Perfect. Oh, there we go. Let me go back to the previous page. So that's what's happening there. So we have that. We have the max and mins. We have the x-intercept, y-intercept. I'm not going to write them out again. Domain's going to be all real. Range is all real. So let's look at P8. And then we can wrap things up after that. Okay, P8.
Yeah.
What's the y-intercept here, by the way? That should be pretty easy. 8. Yeah, it's pretty easy, right? The x-intercept's not easy. I don't know. In fact, actually, I don't think we can do this analytically. I think we need to use graph calculator to do this, or Desmos. So go and do P8. Same thing. List the highs, lows. Go and give P8 a shot. I'm going to freeze my screen. Let's give P8 a shot. We'll check in, and then we'll wrap things up, okay? So give P8 a shot. Yep, so.
Is it, I can put a second trace, how do you put the x-intercept?
Oh, second trace. You pick 0. The option 2, yeah. Okay, so let's punch in the next one. Let's see here. X4. I already said that. Oh, that's because you didn't go to the left and to the right. So you have to first pick a point to the left of the x-intercept, and then a point to the right of the x-intercept. Let me take a look.
That's also mine.
So your graph should look like this, guys, for P8. The x-intercept should be actually, oh, they come out really nice. Wow, look at that. Oh, geez. That's lovely. That's awesome. 1, 2, 3, 4. There are 3 x-intercepts.
I feel like it'd be really difficult. It's unusual. No, this is not a fidget.
Okay, guys, let's put the green toy away. Thanks.
Not a toy. It's worse.
Whatever it is, I don't know. Okay. I see Cooper playing with that. All right, so what are the x-intercepts here, guys? Okay. -1. Good. And there's a bounce at -1. Well, it bounces, right? It's deflecting off the x-axis. I know, it's great. Okay. Y-intercept. That's right. Okay, y-intercept's 8. How many turning points I got? 3. Okay. We got the x-y-intercepts. Don't worry about table. It's all good.
What's it for?
Peaks or valleys, high or low points. Now, focus on this. What's my degree?
Yeah.
Hey guys, is my degree even or odd? Even. The degree is the highest exponent. That's an even number. And my leading coefficient is 1. Which is positive. So it's going to open up, up. So it opens up, up, bounces at -1 because that's what the graph showed. 2 and 4, the graph shows that. Y-intercept, of course, it's 8. High and low points, we already got it from the calculator or Desmos. So you don't need to state them what they are. But they're obviously here and here. apparently this can be factored if you have integers as your x-intercepts. We're going to talk about that on the next page, how to factor this stuff. This is actually a tricky one to factor. We'll talk more about that later. Yeah.
Does mean like it has two values?
The arrows are pointing up. The
Oh,
left
so
arrow and
it's-
right arrow. So that's what we call end behavior, how the ends of the graph behave. That's why it has that name. And it's closely tied to what x is doing. Sorry, what y is doing when x goes towards infinity or negative infinity. So domain's all real. Now, is my range all real? No. The low point here, whatever that is, I gotta look it up because you won't be able to know that until you take calculus, but the range is actually going to be higher than negative 16.94. So my domain is all real. My range is y is greater than or equal to negative 16.95. I'll round it up. And you're not going to learn how to do that until you take calculus. You won't know how to do that until then. You just have to use a graphic calculator for that. So you're gonna major in math, I know it. Yeah, you are. I'm gonna see you at a yeah, a 10-year reunion. Yeah. I don't believe you. Okay. Last bit we'll do. Just factoring. Just make sure you guys are cool with it, and I'll go over some terms, and then we're done. Not just to break it down. We'll see. Go a little more than the first one, and the second one also. Okay, guys, what can I pull out of the first one? What's the greatest common factor of GCF? What do they all have in common for the first one? X. So you get x squared minus 21x plus 20. Now, what two numbers multiply to 20 and add to negative 21? A 7's not a factor of 20. Don't make it too hard. How about 1 and 20? How about 1 and 20? Always 1 in itself. Try that first, right? Because what's it add up to? 21, right? So there we go. But make them negative. It's okay. How about we'll give you a chance to redeem yourself. What's common here? X what power? Okay, what's left behind after I pull x squared?
X squared is 9.
Can't break that down further. It's difference of squares. X. Correct. Yeah. Yeah, that's all. And my x-intercepts would be this: 0, 3, and negative 3. By the way, there's gonna be a bounce at 0 because it's squared. There'll be a bounce there. X equals 0. Oh, because you pull out an x. Because that makes it 0. When you plug in 0 for x, it makes y 0. So you'll be practicing factoring. I'll work out the answer key in a moment. Bunch of terms here. Binomial means 2 terms. In order to be a polynomial, it has to take on this form. Actually, I should have mentioned this in the beginning. That's my fault. In order to be a polynomial, it has to be x raised to a whole number. Very important. You cannot have x raised to a non-whole number. It will not be a polynomial. These are not polynomials, just so you know. Because you have 2 raised to the x power, or you have something on the bottom of a fraction. It's not okay. If it is a fraction with a bunch of variables and it's a rational expression, as long as top bottom are polynomials. Usually you want to go from highest to lowest, left to right. Constant terms, a term has no x. Coefficient numbers in front of the variables. What else can I say here? The degree is the highest exponent. I mentioned that already. So yeah, I think that's all I kind of wanted to say. So I think I'm good for today. So you guys can, it's perfect. You have about 17 minutes to work on homework. So you could work on factoring these. I'm going to work these out also and I'll put my answers up in a moment. Actually, I'll take a picture and just share it with you guys. So work on that. What else was I going to say? And then go to the CPM textbook, work on those problems. And then homework will be due Wednesday. Yeah, and that's pretty much, if you want to do, for those who are planning to do AB calculus, pre-calculus AB honors, you might want to try those optional problems. They're usually pretty good practice. That's all. Use the rest of the time to work on homework, and I think we're good.